Welcome to Advanced Algebra 2 Summer Bootcamp Round 6. I'm your host, Mr. Stark. Thank you so much. And if you watched the 5 videos that led up to this one, thank you. Congratulations. You reviewed some Algebra 1 concepts. Probably were reminded of how much you actually know. And you also learned some new graphing calculator features. Very nice. For this video lesson, we need 2 documents. This one, which is the lesson page, and this one, which is the activity page. There are multiple pages. And you'll see me working through that page full screen with my calculator program. Super nerdy. So let's talk about systems of equations on your lesson page. We'll use your calculator later, but a pencil is all you need right now. The first thing I want to talk about is solving a system of equations. So there are 3 ways we can solve systems. The third way is kind of like the first way. You might remember these. Number 1, substitution. Number 2, elimination. Usually these equations are given to us in general form, which we don't really need to talk about right now. And number 3, what we could do is solve for y, then set the equations equal to each other. So we could do that by hand or with the calculator, which we'll do in this lesson. Now, that third step is really similar to substitution. When you're setting 2 equations equal to each other, you're essentially substituting one equation for y so that you could solve the 2 together. You'll see more what I mean later. Now, how do you solve a system of equations on the TI-84? Well, we let y1 be the first equation, or the left side of the equation, and let y2 be the second equation, or the right side of an equation. Basically, if there are no y values, then you have a left and right side of the equation. Now, let's talk about evaluating equations, which we really already talked about in a previous video, but it was called evaluating functions. So to evaluate equations, really what we're doing is just plugging in. So let's talk about an example, y equals x squared. So for y equals x squared, if we want to find out the value of y at x equals 3, well, we plug it in. We plug in 3 for x, and we square it. So we get y equals 9. So this is what we would do by hand on paper. Now, if we want to find the value of y when x equals 7, well, we plug in 7, square it, and we get 49. Well, I wonder how many of your squares you know, just looking at this table on the right. They should look quite familiar. Pretty much when we know up to 15, that's pretty good. Now, so how do we do this on the TI-84? The screen on the right is what I've shown you already, and that's just on your main screen, and you're pressing alpha trace, which is F4, to pull up the function that you want to plug in. So y1, y2, y3, plug in 4. And then you enter the open parenthesis, put in the number that you want to evaluate at, and then close the parenthesis. So 2 parentheses, one in a different location, left and right. Now, the left screen shows you the table feature in the TI-84, which is the thing that we didn't talk about in the previous video. Excuse me. So the left screen is your table, and you access that by pressing second graph. Okay, and that's all we need to know for now. Now, combining equations. This is kind of abstract right now. The reason I want to point this out is because we'll be doing this in an activity, and there are plenty of ways that we could do this, and kind of a cool shortcut on the calculator. Now, here are the ways to combine equations. And if I would ask you, you probably would think of these, but maybe not right away. Well, the first way is we could add equations or add functions together. Second way is subtract. Third, multiply. 4, divide. But we could also do this unique combination of equations, which is actually called composition. So that's the 5th way. And we usually study these 2 things together. But a composition is kind of like in music where you combine different sounds together from different instruments and make it into something unique. So a composition of functions is where you plug one into the other. Again, like music, where you take one sound and you plug it into what you're composing. Okay, so those are the 5 ways to combine equations, and the shortcut on the calculator is pretty cool. So look at the screen to the right. And in Y3, so let's say we're combining Y1 and Y2. In Y3, what we could do is combine them there and just write them as is. We could say x squared minus 3x. So we're combining them in a subtraction sort of way. But if we press alpha trace, we could use the function notation instead of retyping those equations as is. So we could write y1 minus y2. Now in this case, that really doesn't matter. Typing x squared minus 3x again is really not a big deal. In fact, it might even be less button pressing than doing y1 minus y2. But when you have longer equations, polynomials, multiple terms, then it actually becomes very smart to do this process. So that window again on the bottom right is alpha trace or alpha F4. Good stuff. Now, the last thing I need to make an adjustment for income, what I really mean is revenue. So when we talk about income, that's our money coming in as humans, as workers. But revenue is more of a conversation about money coming in for a company. So we'll replace income with revenue because in this activity coming up, we'll be talking about a company. Ooh, I hope you like it. It's about dogs. I'm a cat person, but I like dogs too. Are you a cat person? Dog person? Yep, classic debate. Which one's better? Now, cost. Let's define cost. Cats are better. Let's define cost. The amount paid for something. That's it. The amount paid for something. So we purchase an item or a service. Or we're providing something, so there's a cost to providing that. Now, revenue, a little bit different. It's the income from selling something. The income from selling something. Now, I could define income, and really all that is money that's coming in from working, either selling a product or a service. Now, profit, many of you know, it's simply the difference between revenue and cost. I would describe that as a financial gain for a company. And the equation would be P equals R minus C. So you could start to see how this connects to the visual above. We just talked about combining 2 equations. We'll be combining a revenue and cost equation in the activity. Now, just a quick thought about these things on the TI-84, that it's all about the graphical approach here. So when I write C equals R, algebraically, I'm trying to find out when cost is equal to revenue. But graphically on the TI-84, what I'm trying to find out is visually where those lines intersect. So that's the break-even point, and we use the intersect option for that, the feature. And then 2 things. One, both about profit. Profit, when the graph is above the x-axis, so profit is above, it's the difference between the 2. So when that value is positive, the company is making money. Cha-ching! That's what we like. And then alternatively, when the profit function or equation or graph is below, like all the points are below the x-axis, the company is losing money. So we're interested in when is profit 0, but we're also mainly interested in when can we make it positive. So that's all the background information I want to share with you right now. And in the next part of the video, you'll just see me with the full screen. Well, you won't see me. You'll see my full screen of the calculator program working through the activity called Going into Business. All right, let's go into business together. Problem 1, setting up the problem. So you decide to start your own business of washing dogs, not cats. Yeah, I don't think that'll work out. First, you purchase $50 in supplies, so buckets, towels, hoses, etc. And when you buy a 32-ounce bottle of shampoo for $4.79, the label says that it will wash a dog 32 times. How convenient. So we're just working through these first 3 questions. Not much to do on the calculator, but we will do some. So find the per dog cost for the shampoo and describe how you found that. Now, if it's $50 in supplies and then it's $4.79 for the shampoo, we really care about the $4.79. So we'll take that $4.79 and find out kind of approximately right. Sometimes you'll use more or less on each dog, but approximately 15 cents per dog. Okay, great, not bad. 2, determine the cost equation for washing dogs. Remember, the cost equation, really cost in general, is the amount that something costs, right? So whether that's a product or service. So we're not going to forget about the $50 in supplies. So it costs 15 cents per dog. So let's go to y equals here. 15 cents per dog, 0.15x, plus the 50 that we paid originally. So this is our cost function. And this is assuming that x is the number of dogs. So if we're just doing a wash of 1 dog, then plug that 1 in and you'll see how much it costs. Okay, now number 3, your mom offers to pay $3 for your dog to be washed. Of course, she gets like the family discount, right? Explain below why you think your mom's price is reasonable, too little, or too much. We're here to make a profit. Now, when I think about this, it costs 15 cents to wash the dog, really. Let's say we charged $1. We'd want to make sure to take some of that dollar and apply it towards the $50 fee, the supplies originally. So what would that be? Maybe we would say $2 at the beginning, but then realize, oh, if we want to make a good profit, we need to charge something like $3. Or maybe more once we get the hang of things. So at this point, I think it's reasonable because it also takes time and water to actually wash the dog. Okay, but we might see that we want to charge more. Problem 2, finding the break-even point. So I talked about this briefly in the lesson notes. So we'll look for that break-even point. Graphing the following equations, y1 equals 50 plus 0.15x. Now I purposely put this here because I want you to see that this is kind of like slope and this is like the y-intercept. So this is the same as y1 that's on the page. Now y2 is 3x, so I'll enter that as 3x. Now that's the revenue function, okay, the revenue equation that based on your mom's offer of paying $3, maybe it's like, kind of like your allowance, that is the revenue function. So with number 4, find the intersection point of the 2 lines. So if I were to just hit graph right now, just not even thinking, I don't see the intersection point of the 2 lines. But when I start to realize that that cost function has a 50 inside, I really want to see where that is. So I want to change my window to include such a large y value. So I'll maybe say 60. Better, I get to see that blue line, which again is the revenue function, but I don't see where the 2 lines intersect. So I'll go back to my window and I'll change the x max. In fact, thinking about this, it doesn't make much sense that we would see the negative axis over here. We're not going to do negative amount of dogs. So let's make our window -5. I just like to see the y-axis. -5 for the y-min. And then the x max, let's pump it up to 20. I'm not sure if that's the best. So now I could see that intersection. So it says find the intersection of the two lines. So we'll do that now. That feature we looked at before, which is a very common feature, second trace intersect. Now, your calculator is asking you something, and we've talked about this before, but first curve, what's the first one? We press enter. Second one, press enter. And then we want to guess where it's at. Now, the guide for your calculator says that you could just press enter, but I like to go somewhat close so I don't forget when I work with curves. Record your answer. So that means our answer is 17.5. We really could round up to 18, but 17.5 is our x value, and the y value is 52.6. I want to show you a little trick really quickly. Second mode, and if you just type x, that gives you that x value. And if you type y, oddly, it's x is a common button, but you have to press alpha 1, enter. So those are the two values. So what's cool is you could do anything with those two values, like you could plug them into other functions or something. Number 5, interpret the point of intersection in terms of your business of washing dogs by explaining the meaning of the ordered pair. So what does the ordered pair mean? Okay. So if we look back up to some of the, like a previous question here, well, first of all, y1 is cost, y2 is revenue, right? But the x values and y values mean something else. So the x value is the quantity of dogs that we're washing, and the y value is the amount of money. Okay, and that amount of money means something different for y1 versus y2. Okay, so once again, quantity of dogs for x and money for y. The next thing we'll do is solve the problem algebraically by setting the equations equal to each other, and it mentions substitution. So really what's happening here is we're setting y1 equal to y2 and just getting all the x's on one side and the numbers on the other side. Okay, so that's something, I'll just do it on this screen here. Okay. So there's the solution. That's the same number that we just came up with on the graphing calculator. So that's handy. We always want to make sure like that what we're doing on the calculator makes sense on paper. In fact, that's why we're doing this stuff together, kind of building on something we already know and seeing it on the calculator. All right, number 7, will you make a profit before you have to buy more shampoo? Will you make a profit before you buy more shampoo? And it says, remember, you can wash 32 dogs with one bottle. So all we're doing right now is just analyzing our answer. We're washing 17.6 dogs, so let's say 18. Or we didn't quite finish the 18th one, right? And that means when we look at the bottle, we've used a little bit more than half of the bottle because the bottle says you could do 32 and 16 is a half. But obviously if that wasn't accurate, in real life, then we'd have to figure that out in real life. But right now we're kind of not in real life. That was deep. Sorry about that. Anyways, this is a real life situation. So that means 18 from 32, you have that many washes left. So what's cool about that is you're not actually paying the 15 cents in a way for the next, 14 dogs? So you're just paying part of your money towards the towards those original supplies. Okay, that's all for problem 1 and problem 2. I have a separate thing set up for the other ones. Problem 3, really thinking about the business now. We're on number 8 and we're changing the equation in y2 to 4x. So we're changing it to a higher price of $4 and we're about to find the intersection point. So this is nifty because maybe we decided that some of these dogs are kind of big, so we need to charge more. So let's take a look at the graph. and it looks quite similar. But what I want to point out, so let's click trace, and notice this is y1. So y1 is our cost function, and if you press up, you go to the other one. Doesn't matter up or down, you just keep pressing down. And this is our revenue function. So I want you to see like this whole area in here, the amount of revenue is below cost, okay? So that break-even point, we found that last time. Like that was a good thing. We broke even. Now the rest, as we do more washes, we make more money. So this space up here, as we go to the right, is what we want to happen. So either we need to reduce those supplies that we purchased at the beginning, which we can't really do after we already did it, or we need to wash enough dogs so that we start making money. Okay, let's find that intersection point. So second, trace, intersect. Notice how I'm right there, but that doesn't mean I'm actually there. So I move left just so I could see that I'm on one or the other curve, the blue one. So press enter, enter again, and then again I just kind of go close. Now the official answer to the intersection is 12.99, so basically 13 dogs, and $51.95. So it's kind of helpful to keep the 2 decimal places for the y value, but we're basically rounding up for the dogs, or rounding down is fine too. So how does the ordered pair change as you increase the price? Well, I don't really know. I can't really compare it visually because I don't have the other one, but the x value is now 12.99, whereas the x value before was 17.5. So basically what that break-even point did was move to the left. It was originally like to the left over here, and now it's here. So what's happening is basically you need to wash less dogs to break even, and that's a good thing. So it's helpful to know what that number is. Now, what's the new system of equations? Number 9, solve that system using the $4 charge. So I don't know, let me do that again right here. So this is the algebraic work that we would usually do first and then support it with the graphing calculator. Okay, let's now take a look at the table. This is the new feature that I want to show to you, which is super helpful. So let's click second, graph, and you could see a table. And so that Y1, remember, was our cost. It cost $50 to wash 0 dogs, and then this is our revenue. So what's really neat about this is I could go to Y equals, and I could change this back to 3, and then do another one for X. And I could see both of those revenue functions at the same time. So let's say I washed 10 dogs. My cost is $51. My revenue is either 30 or 40. So it's cool, as you could see, like, oh, well, I could make 40 instead of 30. Or if I press it down, I could go and see what it would be at 20. Now, I just want to point out, maybe your X values don't go up by 1. Whether that's the case or not, I want to show you this feature, second window. And you could set a table start. So I could put 0 where I want the table to start, and I want my delta table to be 0.5 instead. Or maybe I'm just going to choose between, I need to do like either 10 washes or 20 washes or 30 washes or so on. Pardon me. So you could change how much the table changes. Okay, so let's make that 1 again. And then the next thing I want to change with you is, and this is on this page, this activity sheet, the table is set up for you, but let's change the independent to ask. So what happens now is, instead of giving you all the values, the table is asking you for a value. And so that's when you want to find out, that's when you want to evaluate or plug in specific values into the equation. So let's do that with number 10. I just wrote ask next to number 10. I'm setting up the table to ask. So we're asking, how much does, what's the profit by finding the difference in two values, okay? So let's plug in 13. And the profit, remember, is revenue, so 39 minus cost, 51.95. So that's a negative revenue. So we're just losing money. And then if we did 13 washes at $4, we'd be making 5 cents. Okay, now there's a quicker way to do this, which is basically what's being set up, for you. And we'll do that quicker on the next video here, or next part of the video. Sorry. Okay, so that's 5 cents. Let's do 14 washes. So now at $4, we do 56 minus 52.1. So $3.90. Let's do 15 washes. So 60 minus 52.25, $7.75. And then 20 dog washes. Okay, this could be good. This could be good. And in both cases, whether at $3 or $4, we would make money. And that makes sense because it was like 17 that we made money with Y2. Okay, that's a great feature, the table feature, table setup and table. So graph, second graph. Problem 4. Now we're calculating the profit. We're not just, doing this by hand and comparing those two values. So now what we want to do is go to y equals, and I'm going to set this up just like the page does. So I'll clear this. So y1 is our cost, y2 is the revenue, and we're using the previous values in number 10 to do this. So, but the first thing we need to set up is y2 minus y1 in y3. So we do alpha trace y2 minus y1, alpha trace y1. Just so you know, whether this applies to you or a classmate, whatever, is that this feature, alpha trace, that's only available with the newest OS. And if somebody doesn't have that, or if you've somehow forgot that shortcut, the button to press is vars for variables, and then you go to yvars, and that's in function. So there they are right there. But really no need to do that unless you don't have that feature. Okay, now let's graph this. And we could see this is cost, this is revenue, and then this over here is profit. So maybe I want to change the window a little bit more, and I'll go to Xmax 30 just to see more. And number 12 is asking you to describe the graph. So let's talk about that briefly. First thing is I want to mention that all three of these are lines. So it's a linear graph, and we're talking about the black graph now specifically. The graph is negative all the way up to this value here. So I could find that value by pressing trace up and just getting close. I'm guessing that it's 13, I don't really care too much. So it's a negative graph until this point, meaning it has negative values, not a negative slope. But it does have a positive slope because it's increasing all the time. And after 13, to the right here, the graph is positive. So profit is positive after 13, meaning if you wash at least 13 dogs, you'll make a profit. Question 13. So now we're really applying everything. What does it mean to have points on the graph that lie below the horizontal axis? So what does it mean for these points down here? Well, that means we're losing money. That's a negative profit. That's a loss. And then what does the point on the graph on the horizontal axis represent? What does this point represent? So we could go up to here where cost is equal to revenue, down here where cost is equal to revenue. So it's a break-even point. And again, this is not perfect because we found it as 12.99. And then explain what you know about points that lie on the graph above the horizontal axis. So we kind of talked about that. How would you phrase that? Making money. We're making money over here. It's pretty great. Making money washing dogs. Well, that's all I have for you right now. A great follow-up would be to do the 4 exercises in the extension homework section, the last page of the activity. I also wanted to mention that about systems of equations, you can have 3 or more equations to compare and find intersection points or points in common. But in this lesson, we were just touching the tip of the iceberg and learning about some of the calculator features. So I hope you enjoyed the lesson and look forward to teaching you some more stuff. Thanks a bunch.